Hello, welcome to my channel. Today, I will be making stunning crystal from sodium chloride and magnesium sulfate. Please watch the video until the end to see the process and a simple explanation of the crystals I've made. Before I begin to show you the steps, I will share the necessary equipment for the crystal making process. First, you need 2 glass water. Second, you need 2 flat containers with flat surfaces. Third, you need a fork. Next, a sieve. And the most important compound, sodium chloride or salt. Hot water. Kitchen tissue. And last but not least is food coloring. Now, we begin to make the crystal. Pour the hot water into the glass. Then, add the sodium chloride to the hot water. Stir the mixture using a fork. If all the sodium chloride dissolves in the water, add more sodium chloride and stir until the sodium chloride can no longer dissolve. This indicates that now we have a concentrated sodium chloride solution. After that, use the sieve to prevent any undissolved sodium chloride from mixing with the solution. Mix the solution with food coloring and stir it together. Use another container and repeat the same steps, but now do not add food coloring. The aim of this is because I want to make it have a variety of colors. Now, we use magnesium sulfate or Epsom salt to make another crystal. Repeat the same steps. Use hot water to dissolve the magnesium sulfate until no more magnesium sulfate can dissolve in the water. When you look at the bottom of the glass carefully, you will see the undissolved magnesium sulfate. This is the indicator that now we have a concentrated magnesium sulfate solution. After that, don't forget to use a sieve to prevent the undissolved magnesium sulfate from mixing with the solution. And now, look at the stunning square-shaped crystal. This is the crystal formed from the sodium chloride after I let the solution sit overnight. After I took the sodium chloride crystal out of the container, the color differences were not very clear, but I successfully created a sharp-edged crystal. This is the stunning needle-like crystal. It was formed from the magnesium sulfate after I let the solution sit for a week. Even though making crystals seems simple, there are few things you should be aware of to ensure the perfect formation of the crystals. Let the starch solution sit still in the container, keeping it somewhere away from people. This minimizes vibration and disturbances, allowing the crystal to grow uniformly. Now, this is the physics behind it. Sodium chloride has a first-centered cubic crystal structure, and magnesium sulfate has a monoclinic crystal structure. This actually relates to the shape of the crystals. The first-centered cubic structure causes the sodium chloride crystals to form a cubic shape. For magnesium sulfate, the needle-like crystals are due to anisotropic growth caused by hydration and the lattice structure of the monoclinic system. Monoclinic crystals have only one axis of symmetry, with the other two axes having different lengths and angles. The presence of the hydrogen water in the crystals affect the lattice and creates an elongated structure. The asymmetric growth along different axes causes the magnesium sulfate to grow easily in one direction. As for the packing factor, 70% of the unit cell is filled with ions, while the remaining 26% is empty space. The high packing factor influences the strength and the hardness of the sodium chloride crystal, but at the same time, it is also brittle due to the ionic bonds. However, for magnesium sulfate, the packing factor is not calculated because of its hydrated nature. In the context of solid-state physics, sodium chloride exhibits ionic bonding between Na+ and Cl- ion. These ionic bonds result in strong but brittle crystals. The defects in sodium chloride crystals are primarily due to dislocations, vacancies, and edge dislocations. These defects can cause uneven crystal growth and affect the strength and brittleness of the material. For magnesium sulfate, hydrogen bond exists between water molecules and sulfate ions. These bonds influence the crystal growth, leading to the formation of needle-like shapes characteristic of magnesium sulfate crystals. Based on my experiments to grow crystal, one question that might come to mind is, how can we grow larger crystals? For sodium chloride, the formation of crystals requires the slow evaporation of saturated sodium chloride solution. This process allows the ions to organize and crystallize over time. Maintaining the purity of the solution is essential for the crystals to grow uniformly. For magnesium sulfate, growing larger crystals requires cooling the saturated solution at a slow rate. The use of seed crystals can aid in uniform growth. Additionally, temperature and impurity significantly influence the size and uniformity of the crystals. Thank you for watching. Don't forget to like this video and I will see you next time.